Hello and welcome to the tutorial for QuickSound Pro. Installing QSP is really easy. Just import the package and you're ready to go. Let's get started with the basics. We're going to create a button that plays a sound when it's pressed. To handle button events, we'll add the audio events component. Then, we'll add the button click event handler and reference our button. The button will send an event that notifies our audio player component, which we'll create shortly. If we try to create a new event here, we'll get a warning saying that no registry asset is selected. All events defined in your game are registered in a registry asset. The asset pack is shipped with a default registry asset named generic events that we can use for this purpose. Now we can create our very first event. It's time to create the audio player. Right-click and select Event Player. Let's create a new event handler and don't forget to specify a registry for the events. Now, back in our event handler, we can select the UI click event we created earlier and choose an audio clip to be played. Perfect. Let's try it out. Next, let's add a sound effect for when the button is pressed and another for when it's released. We'll choose the same audio clip for both, but set a custom pitch for the button down event to differentiate the sounds. We'll also update the button to trigger events when it's pressed down. There it is. We can also trigger these events from world objects. We just need to add a physics raycaster component to the camera object. Now, if we create a new button, we can use the audio events component here to trigger the same events. Let's check it out. One of the most exciting features of QSP is called Affectors. Affectors are modules you can add to your event handlers to modify the way a sound effect is played. They can affect audio playback in countless ways. Randomizing pitch and limiting the simultaneous playback of the same sound effect are just a few simple examples of what Affectors can do. Let's try out a few of these that are included with the asset pack. Don't forget you can also create new effectors on your own. For starters, let's add a delay effector. It will simply delay the sound effect without any allocations. Timescale pitch synchronizes the pitch with the timescale. By the way, there is a help button that can guide you through most components and modules. To make debugging easier, there's a console log effector, which you can use to log messages in the console when the sound effect is played, completed, etc. Another useful set of effectors are the limiters. they can cancel sound effects at certain times. For example, the listener distance limit helps save resources by preventing sound effects from playing when the listener is too far from the event source. Or the simultaneous voices limiter prevents multiple sound effects from playing at the same time. The time frame based limiter will prevent too many sound effects from being played within a given time frame. In this case, the sound effect can only be played once per second. Let's see this one in action. Notice that I've applied the limiter only on button release. There are situations where you're working with multiple related sound effects, such as footsteps. You can group these audio clips together by creating an audio group asset. Notice that there are some configuration options for each clip that you might find useful. Then, you can configure your event handler to play these sound effects randomly. For footsteps, I personally find it ideal to play all the sound effects in the group exactly once in a random order before starting over. In this case, I want each clip to have an equal chance of being randomly selected, and I want to ensure there is no repeating until all clips in the group have been played once, so I'm selecting no repeating sequence. While this step is optional, you can always have more configuration options by creating the QSP engine object. You can select or create a settings asset to further configure the engine. At the time of creating this tutorial, there aren't many options, but more might be added in the future. Let's get familiar with the API a little bit by playing a simple sound effect when the button is pressed. For this, I'm going to create a new script called API test. I'll define a serialized audio clip and create a public method that I'll call on button click. That's it. Now let's add the component and call the play method. Next, let's try adding a random pitch from 1 to 3. The prepare and play methods return a struct that you can use to control playback, for example, stopping the sound, or receiving notifications when the sound is completed, or even registering effectors. You can also yield return the context in a coroutine or awaited. All of these methods are efficient and allocation free. Another small feature you might find useful is locating your players by their alias. Here's how it works. Let's try adding an effector to our sound effect using code. All effectors are serializable, so you can easily use them in your components. In this case, we want to fade in the sound effect. Make sure to set the update parameters every frame to true, otherwise the pitch and volume won't update over time. As you can see, the effector can be configured in the inspector. Finally, I'm going to show you how you can trigger audio events from your code. Implement the registry provider interface first, then add a reference to registry asset. Now you can define as many events as you'd like. Finally, we're going to trigger an event inside the play method. Another important feature of QSB is its integration with Unity's Addressables package. It just works right out of the box. Install the Addressables package and you'll notice numerous changes in the editor. Now we have the addressable audio clip option here. Also, we can now create addressable audio groups. We'll get back to addressables later and explore this feature further. This brings us to the Ambient Sounds feature, which is used for looped sound effects. You can use this feature in 3 ways. Use dynamic point when you want the sound to be played along an object, such as a river. Inside bounding box is useful for playing an ambient sound when the listener is inside a designated area, such as a forest or underwater. And choose the static point when you want to play a sound effect at a fixed point in the world. With that said, let's create a simple static point player. Since the spatial blend is set to 1, the sound is played in 3D. Now, let's try the dynamic option. I'm going to scale this cube to resemble a long river. Now, let's create a dynamic point ambient player and assign the audio clip. Let's try it out. As you can see, it's not working properly. That's because we forgot to specify a collider along which the sound effect should move. Let's fix that and try again. This time, the audio source updates as I move the camera along our imaginary river. Finally, let's see how the inside bounding box player works. As you approach the environment, the ambient sound gradually becomes audible. And when the camera is inside the cube, the sound effect plays at full volume. We've also got you covered for handling music in your game. There are 3 quick configurations for this. The sound can be played in 2D or 3D. In 3D mode, you'll need to choose whether the sound effect is static or moving in the world. Either way, similar to the ambient player, artist options create the same component, but with different pre-configurations, so you can change them at any time. The asset pack is shipped with 2 modules for the track player component. You can also choose to skip the modules and control the track player with code, or even write your own modules. For instance, you could use the single clip module, which is as simple as it gets. Let's check it out. There are some editor tools here to work with. Notice that if we stop the song, it will play again. That's because the modules are processed when the song is not playing, and in this case, we have looping enabled. If you want to fully stop the music, you should disable the player component. Now, let's try the playlist module. Here, you'll need to specify an audio group asset containing all the songs you'd like to play. Next, let's take a look at an interesting feature, audio graphs. Graphs allow you to create complex audio logic without writing code. You can think of it like a shader graph for audio. It supports loops and conditions, provides easy control over pitch and volume, and even supports asynchronous operations. Let's take our button click example and implement the button release sound effect using a graph. We'll need to create a graph player and a graph asset. Opening the graph presents us with a blank canvas where we can create our logic. Execution starts with any of the yellow nodes. For example, the start node is executed as soon as the graph begins executing. We're not going to use that here. Instead, we'll use the handle event node. Now, if we try to access the events as usual, we'll get a warning because we haven't specified the event registry. Let's fix that by selecting the graph asset. This time, we can browse through our events and choose to handle the ClickUp event. Upon execution, we want to play an audio clip. Let's assign the clip and try the graph out. Voila! Now, let's go ahead and play this clip in a loop. We'll start by repeating the same clip 3 times at 100 milliseconds intervals. There's a really useful node called graph time. Using this node, you can determine how much time has passed since the graph started executing or since the current event was triggered. With that said, let's try making the pitch progressive. We want to use the time elapsed since triggering the event. Let's check it out. I don't know about you, but I don't like having so many hard-coded values. Let's change that by introducing parameters. Now, if we go back and select our graph player, we'll find all our parameters there, ready for configuration. Let's return to addressables. If we rely solely on the players to load our addressable audio clips, we may be disappointed because it takes time for Unity to load them into memory. To mitigate this, we can use preloading zones. First, set up our players to reference the clips using addressables, then create box zone or a listener distance preloader to ensure all our clips are loaded asynchronously into memory as the player enters the area where the sound effects are needed. As you can see, the assets are preloaded as soon as the camera enters the area and unloaded once the camera moves a certain distance away. Thanks for watching this video. We kept the example simple for clarity, but if you're looking for more advanced samples, be sure to explore the asset pack.